Hello everyone, I am Dr. Fawzul Atiq. I am giving some series of lecture for the course Probability and Statistics. So in the last lecture, we discussed about the mean, median, mode for the case of ungrouped data, right? And then we, in the previous lecture, we discussed about the statistics, the introductions of that. So because we finished with the mean, median, mode of the ungrouped data, then we should have a comparison between mean and median, that why the median matters. Once we have the mean, why the medians matter. So the mean, which is the average, is strongly influenced by extremely large or small values called the outliers. How? So suppose, let us take an example. So look at the data, right? And if you just find the mean of these data, if you find the mean of these data, you'll be getting the value is 48.23, right? Okay, this is a good one. Now, uh, the first entry, if you just change it with a very big number, right? If you change it with a very big number, maybe you change it with the value 1800, which is far bigger than all the values of these numbers, right? So which is basically extremely large number. So this kind of number we called it as outliers. So if we change this 70 by this 1800, and we can see that the mean value will reflect as 105.9, whereas the actual mean was, when it was 70, then the mean was 48.23. So if you have such kind of outliers or is some extremely large value, a single extremely large value, so which is not the case for all of them, only one value is there, which is a very big number. In that case, mean cannot give you the actual like a picture of the data, because it is showing that average is 105.9. That means you may understand that all the values are nearly between 105.9, whereas it is not the case. It is because of this entry it is happening, correct? So in that case situation, think about the median. What was median? Median is the middle value that split the data into two equal halves, correct? So even if you have a very large number, if you replace the 70 with the number 1800, will the median have much effect? No, right? Even if it has, it may have only one unit here and there. Like, I hope you got the point, right? So median is very, very helpful if you have such kind of outliers, right? So therefore, what is median? That we already know. The median is the middle value that split the data into two equal halves, and it is at most half the values are below it, and at most half the values are above it. That is the median, right? So at least half the values are below, and at most half the values are above it, above the median. Like what I mean that, like if you have a distribution something like that, so if this is the total probability, then half, that means here somewhere the median should be here, so that the half will be, so that the half portion is here, and after onwards half portion is after the median. Okay, okay, next. Then the sample median is what? That it estimates the population median from a sample, right? And for sorted data, the median is the, like if you have a sorted data, first you will collect a sample from the population. Then it is a very little bit smaller number of quantities you will have. So you sort it out, like you can write them in ascending order. That's what we have done it in the previous example. Then the median is the middle value of the number of values. If it is odd, if the number of values is odd, then the middle value is the median. Or if the number of the data is even, then the median is the the two middle values average value. Correct? Then it is very much robust to outliers. It provides a better sense of central location for skewed data. So even if you have a very big number, very small number, it will gives you a clear picture. Now you think about the how to calculate the population mean. Now the population is a very large quantity, right? Like it is not the sample that you will have that only few data and you can sort it out and you can find the median. So population median, we can define it using probabilities. How? Because we have understood that a median uh, is the one that uh, that is the at most half the values are below it, right? A median is such thing that is at most half the values are below it and at most half the values are above it. So in terms of probability, if you calculate, so for any random value, for any randomly chosen value, if I want to calculate P of x greater than m, so this value will be at most half, right? This value will be at most half. Similarly, the if I want to calculate the probability of x is less than m, this value is again at most half, right? Because you have the whole thing is like that, then median is somewhere here that divides the whole region into two parts, like almost half of it. Suppose you have a region like this, so the median divides the part like that. So if you want to calculate probability of x is greater than half, so it can be maximum half. If you say that probability of x is less than m, so it can be again maximum half because the total value is 1, no? Because the total value is 1. I hope you got it. So that is the probability that a randomly chosen value is greater than m is at most 50%. That means tail on the right is at most half and tail on the left is again at most half, right? So therefore we can say that a number median is a number m such that p of x greater than m is less or equal to 0.5, p of x less than m is again less or equal to 0.5, and then we can say make that statement. Now then computation of population median for continuous distribution. So how we can compute the population median for continuous distribution? Now we have these two equations, right? We can solve it actually. See, if I have p of x greater than m and this is less or equal to 0.5, what does it mean? Can I not write it as 1 minus p of x is less than m, because this value is that and which is given as 0.5, and therefore I can write it as p of x less than m. That means I am taking it another side and this value is actually greater than or equal to 0.5. So I got this one equation and another one I already have it. P of x less than m is less or equal to 0.5. This is equation 2. So if I have this equation, solve equation 1 and 2, what it will give? It is actually giving you as p of x less than m is equal to 0.5. Right. Now p of x less than m is what? If you write it in terms of cumulative distribution function, this value is actually functional value of the cumulative distribution function at the point m. So f of m is actually 0.5. I hope you understand. So median is such a value for the case of a continuous random variable. Median is such a value such that its cumulative distribution functions at the median point, the functional value of the cumulative distribution function At the median, it is 0.5. I hope you understand. So now if you have this concept with you, if you have this concept, now we can calculate the median for any kind of continuous random variable, right? Let us have an example. So calculate the median for a population which follows uniform distribution on AB. So therefore, what we have to do, we should have the cumulative distribution function of the uniform random variable, uniform distribution, that we already know. So for the case of a uniform random variable or uniform distribution, probability density function is this one that we have already done. And we also calculated the cumulative distribution function fx for different values of it. So fx is this value. Then what we have to do to get the median? We have to solve the equation f of m is equal to 0.5. Right? So for that, what we'll do? It is basically the value as f of m equal to 0.5. So therefore, we can say that maybe m minus a divided by b minus a is equal to 0.5. And 0.5 means it is 1. Now, if you solve m from this, we'll get actually m equal to, if you just simplify it, we'll get m equal to a plus b by 2. Now, if you remember, if you just do the, if you write the distribution of the uniform random variable, so this value is that height is b minus a, 1 by b minus a, right? So this region is somewhere like that. Now you try to tell me, just looking at this picture, which point gives you that the probability will be half, right? That means the region, which point will divide the region into two parts? Is it not between the midpoint of A and B, so that it will divide the region into two parts? So is it not the median? Now what is this point? It is A plus B by 2 only, right? So from the geometry also we can see, and you already calculated, yes, median is m equal to A plus B by 2. So our, like, we can convince ourselves with this. Hope you got. Similarly, if we want to calculate the median for the exponential and population with parameter lambda, we can also do that. So for that, we need, again, we need to have the probability density function, and then finally we need to have the cumulative distribution function, which we already done in some of our previous lecture. So in case of a exponential population, exponential distribution, cumulative distribution function fx is 1 minus e power minus lambda x. Now, how to get the median? To get the median, we have to solve this equation. F of m must be equal to half. So what is that? Then we can put the value 1 minus e power minus lambda into m is equal to half. So e power minus lambda n must be 1 minus half. So it is half. Now I have to solve for minus lambda n. So you take log on both sides. So it will be minus lambda n must be equal to ln of half. Right? So this minus we can observe in the other side. So therefore, lambda into m is equal to ln of 2, because minus of ln half is equal to ln 2, and therefore the median m is equal to ln of 2 divided by lambda. Got it? So therefore, for the exponential population, the median is ln 2 by lambda. And then think about this one. Calculate the population median for normal population with mean mu and variance sigma square. What should be the median of the normal population? If you remember, we have the normal population is, if you just try to see the curve, it is the bell-shaped curve, right? Right. And then you know that its mean is divides the curve. It is actually symmetrical about its mean, right? So mean is the point, which is the mu. It divides the curve into two parts. So therefore, in case of a normal population, what should be the median? Do I need to calculate? Even if you calculate, you will get the actually the median is the its mean, right? So in case of a normal population, the median is equal to its mean. Median is equal to its mean, and which is mu. So we don't need to calculate it. From the geometry, we can easily say, right? So for x is normal in mu sigma square, where mu is the mean and sigma square is the variance. Then the population median of the normal distribution is mu. I hope it is clear. Now, there is a natural question that in any continuous distribution, does such m always exist? Because how we are calculating? We are solving this equation fm equal to 0.5. So in case of a normal distribution, will it always exist? Yes, if you have a continuous random variable, it is always exist. Why? Because in case of a continuous random variable case, the distribution function fx is actually continuous function and it takes the values between 0 and 1. So by intermediate value theorem, you will have at least one m such that f of m equal to 0.5. Right? Because if you have the fm, suppose fm value is something like that, it takes the value between 0 and 1, the height is 0 and 1. So if you, so at the point somewhere, that half point it should touch. So there is should be a point m such that f of m is equal to 0.5 by intermediate value theorem. I hope it is clear, but it is not the case in case of a discrete random variable. So in case of a discrete random variable, you may not have any solution for the case of fm equal to 0.5, like this case. Because it is not a continuous, you can see easily that it is a stepwise, it's a jump function, right? The distribution function, cumulative distribution function. So here this is the point fx is equal to 0.5. So there is no point such that it is overlapping with it. So you do not have any solution here. Even sometime you may have infinite number of solutions. Suppose for this case, for all the number between 2 and 3, the value of f between 2 and 3 is actually 0.5. So how many values m you will get? Here you will get infinite number of values you have, right? So for both the cases, you can separately calculate median. So if you have no solution, then what you will do? You check the nearest value of x such that f of x is equal to 0.5. So nearest value of x is what? Smallest x. It's not nearest, but you will find the smallest x such that fx is greater or equal to 0.5. So the smallest x is 2 such that its value is 0.5. This is the smallest point. So in this case, median will be 2. Now, if you have the infinite number of points, that interval solution, such that for all of them, the value is f of m value is 0.5. In that case, what will be the median? That means it is the whole interval, the f m value is satisfying. So what will be the median? In this case, the middle of this interval will be reported as median. So in this example, the median should be the middle value of 2 and 3, which is 2.5. Right? So these things I'm going little bit first because just you should have an idea how to calculate the median in this case, the discrete case. Okay. And then suppose that the random variable x has mean is mu and median is m. Then x is said to have symmetric distribution if you have m is equal to mu. Now, what do you mean by the symmetric case? Symmetric case is actually wherever you have median equal to mu. Now median is what? It is the midpoint. And mu is what? If you just try to recall the geometry of the mean, it is actually the center of mass, right? It is the center of mass. Like suppose if you make an wire, the density function, if you make an wire, so mean is the point such that if you take the wire, it will be balanced from the both the side, right? So it is the center of mass. So if you have a curve like this, what will be the median? Definitely the, like, what will be the center of mass? So it's somewhere here, right? So the center of mass will be somewhere here. So it should be the mean. And what should be the median also? Because median divides the whole region into two parts. So the median is also here. So the median and mu are same, right? So you can see it is a symmetric distribution. Yes, we can see it is a symmetrical region, which is a symmetric distribution. Now again try to understand that if your median is less than mu, what does it mean? Your median is less than the mean. Now mean is what? It is something like the center of mass, as I said. And median is the midpoint that divides the whole region into two parts. So is it not the case that you will have such thing that if for this curve, the center of mass can be somewhere here, center of mass can be somewhere here, and median is what? Median will divide the whole region into two parts, so median can be somewhere here. So this will be the point for median. Now you see that m is less than mu, right? So if your median is less than the mean, you will understand that it is a right skewed. You can see it is little bit skewed in the right side. Similarly, if your median is greater than mu, it will be left skewed. In this case, the region will look like this. So it will be left skewed. Correct? So median somewhere here, whereas mean will be somewhere here. So that median is greater than the mu, so mu is less than. So I hope you understand the this three picture. It is clear to you. Now in the last class we discussed about the mean median mode for the case of a ungrouped data, right? Now what if you have a group data? So there are some formulas. Just you have to remember this formula. So there are some justification on them. I'm not going to the detail of it, how the formula came. But if you just remember and you can put the formula and you'll get the answer, right? So now we'll discuss the mean, median, and mode for group data. Because we know that mean, median, mode for ungrouped data. So what if your data is grouped? So the mean for group data is given by x bar equal to summation of fi xi divided by summation of fi. What is fi? Fi is the frequency of the ith class. Now we all know that if you have a group data, you will have a frequency distribution table, right? So you'll have each intervals, each class mark, right? And then some frequency table that in this interval, this many frequency, this many number of elements you have, data you have, correct? So therefore, we can have the frequency from the frequency table. So fi equal to frequency of the ith class, and xi is what? The class marks the midpoint of the ith class. And how you can calculate? For each of the interval, for each of the class, the lower limit plus upper limit divided by 2. So in this way, you can calculate fi and xi, and then the mean is x bar equal to fi xi divided by summation of fi. Now let us do an example. Look at this thing. So find the, okay, sorry, it is the, I took the big one. Yeah. So find the mean of the following group data. So I have a group data. It is given here. Now see the one frequency distribution table we have. The class intervals are 0 to 10, 10 to 20, 20 to 30. Frequencies are 5, 8, 15, 16. So what we have to do, we can find the mean. Uh, then what I need the xi. Somewhere I need the xi. FIs are already given. I need the xi. What is the midpoint of that? And then I need that summation of fi xi. Correct? So fi is given, xi I need to have, and then xi means what? The midpoint of them. So I already have a table like this. So xi is what? The midpoint of the first window. What is the midpoint of it? It is 5. So therefore xi is 5. Then I need to add up all the FIXI. So the FIXI for the first one, it is 5 into 5, so it is 25. Similarly, midpoint of the second one is 15, frequency was 8, so FIXI is 120. Like that, we can finish the table. Now, in this case, the last one, midpoint is 45, FIXI is 6 into 45, it is 270. So we can do that. And then how to calculate the x bar? So x bar is summation of fi xi. So if you add up all of them, what value will be getting? You'll actually get the value is 1350. So x bar is equal to 1350. All the values you add divided by summation of fi. That means if you add all this value, you'll be getting summation of fi. And that value is actually 50. So if you simplify, you'll get the mean is actually, for this group data mean is 27. Very easy. So if you know the formula, then you can easily find the mean of a group data, right? And the formula is this one. Similarly, we can have a formula for the median. What is the median formula? The median for a group data is equal to L plus n by 2 minus f by f into h. Now, what are these things? So first you need to determine the what is the median class. So determine the median class. What is that? Where the cumulative frequency reaches or exceed n by 2. So we know that how to find the cumulative frequencies. Right? We have done it in the previous lecture. So where we have to define the class where the cumulative frequencies reaches or exceed the n by 2. What is n? N is the number of data point. Correct? So total frequency. N is the total frequency. L is what? L is the lower boundary of the median class. So once you identify the median class, then you can find L. N is the total frequency. So summation of Fi. F is what? Cumulative frequency before the median class. We'll have an example. F is the what? F is the frequency of the median class and H is the class field. So this is the formula for median. Now let us do an example. So look at this data. Now what is n here? N is the sum of the frequencies, right? So n is equal to, we have already seen in the previous example, n is equal to 50. Correct? So n by 2 is what? N by 2 is 25. Right? So n by 2 is actually 25. Now you see that you have to identify the median class. What is median class? Where cumulative frequency reaches or exceed n by 2. So let us find the cumulative frequency. That's CF. I'm writing cumulative frequency. So it is 5. Next is 5 plus 8, it is 13. Next is 13 plus 15, it is 28. Then 28 plus 16, it is 44. And then 44 plus 6, it is 50. So this is how we can find the cumulative frequency. Now you check the median class. Which one should be your median class? So where cumulative frequency reaches or exceed n by 2. N by 2 is what? N by 2 is actually 25. So what should be the median class? So this class where it is reach or exceed the median, exceed n by 2, right? So this will be your median class, 20 to 30. Now you defined already your median class. Then next is L. What is L? L is the lower boundary of the median class. What is that? It should be 2, definitely 20. It should be 20. Next is N. N is the total frequency. We already calculated N is 50. Next is F. What is F? F is the cumulative frequency before the median class. So cumulative frequency before the median class. So it should be 13 then. So before the median class, what is the cumulative frequency? It is 13. So capital F is 13. Next, small f, frequency of the median class. What should be the frequency of the median class? It is 15, right? So small f is equal to 15. And what is h? H is the class width, which is 10. So we got all the values. Now just put it in this formula. You will get the median, right? So oh yeah, I already have the solution. So if you put all the values, n equal to 50, n by 20, therefore L is equal to 20, F is 13, small f 15, H is 10. If you put the value, you'll be getting the median is 28 for this group data. I hope it is clear. Then finally we have the last one, which is the mode of group data. Now again, we have a formula to find the mode. It is this formula, L plus F1 minus F0 by 2, F1 minus F0 minus F2 into H. So like the previous one, we should have a model class. We should identify what is the model class. So model class is what? A class having highest frequency. Now, once you identify the model class, you can find the L lower boundary of the model class, F1 frequency of the model class, F0 is the frequency of the class preceding of the model class, F2 is the frequency of the class succeeding the model class, H is the class width. Very easy formula, right? So again, for this example, what should be your model class? So which is having the highest frequency? Which is having the highest frequency? What should be the model class? Yes, definitely. This one has the highest frequency, right? So this will be your model class. Then what is L? In this case, what is the lower boundary of the model class? It is 30. What is F1? Frequency of the model class. F1 must be 16. F0 is what? F0 is equal to frequency of the class preceding the model class. So it is 15. What is F2? It is the frequency of the class succeeding the model class, which is 6. And H is the class width, which is 10. So we got all the values. So therefore, if you put them in the formula, we'll be getting this answer as 30.91. Now you may have another question, natural question there, like if you have that there are two model class. So we can find two mode of it then, because we have seen for a ungrouped data also you may have two mode or more than one mode. So in case of a group data also you may have them. So if you see that there are two model class, so you can separately find their mode, right? Using the same formula. I hope it is clear. So I hope you enjoyed this lecture. These are, I hope they are helpful. I went maybe a little fast, but these are just a formula. So if you practice it, you will understand it is very easy, right? So in the next class, we'll come up with the new content. Thank you very much. You may give your feedback in the comment box. Thank you.